It's unknown for all my windows. That's been fortunate, but it's fine.
Welcome, folks. As you're trickling in, we're getting set up. Olivier is going to kick us off. He's getting his screen share figured out.
Okay, there we go. Now works.
Let's see it. I'm not yet getting the screen share.
No, but now I can at least see my screens because it was all
Perfect.
unknown.
Perfect.
Let's find the right one.
While we're waiting, how y'all doing? Happy Friday. I got a thumbs up. Dirk's like the one other person besides me actually on camera.
Yeah, I would, but I'm quite sick, so I'm
No worries.
trying.
Thank you for still being willing to kick us off then. Appreciate it.
Yeah, no worries. Okay, there, finally found it. Sorry for the delay.
Awesome. All right. Well, I'll hand off. Would you, if you'd like, I can keep an eye on the chat and just flag things as they're there so you don't have to pay attention to it. And then, yep. So welcome everyone. I'm going to hand over to Olivier. He kicked off probably the most epic thread we've had in the AI in Action channel talking about Claude and subagents. So he's going to present about his approach and workflow. Sounds like he's sick and he's in the EU time zone. So he'll kick us off for the first 20, 30 minutes, and then we can continue the conversation. And with that, I will go off camera, hand it over to you, Olivier.
Great, thank you so much. Okay, so to give you some background, everyone who's watching, Markoff is an AI engineering studio. We're based in Antwerp, and long story short, we're focused on the automation of accounting systems, so end-to-end accounting, and we're also in medtech now bringing both systems to production on like a pan-European scale. For me, with Claude Code, and the really big unlock came around the 4 model series release, and then these subagents just make things a lot more reliable. I think it's important, even though I won't go into this in high detail today, that everyone is aware of how we get to the point within Markov where we start using Claude Code, right? So for us, the big learnings have been that as the models have been getting better at coding, so actually, for everyone who's been working with these models for a long time, I'm sure you'll know, like a few years, maybe even double-digit months ago, they were still making a lot of syntax errors. That's not really the case anymore. And then the models have gotten pretty good. So now we've come to the point, at least for us internally, where we will often, and this is like, in the scope of like internal tools or like prototypes for customers, because we also do a bit of consulting on the side. Our flagship products are medtech and accounting, so fintech, but we also do a bit of consulting on the side because we haven't raised any capital, and it's a nice way to generate some cash flow. So what we have is basically on my screen, you'll see we have so this is kind of our directory, and all of our prompts that we share within our team are stored in here. The main reason that I'm sharing all of this, even though, I think a lot of people would consider this to be quite proprietary data, is because in a few months, it's all going to be irrelevant anyway, because I'm pretty sure that, at least that's been my experience so far, all this kind of harnessing and scaffolding, as the models get better, it just gets washed away. So maybe I'll be able to help some people in the coming months with this. So as you can see, we have these like architecting prompts. We can see we have these like subsections of prototypes. We have Jinja, Fast API, local, Azure. So this is a prompt that we use to create prototype plans for like the really, really quick prototypes that will just like run our machine. Like we don't even deploy to Azure. It's like for super quick customer demos. And this prompt is basically like, it's catered fully to our stack. It has like a lot of the methodologies that we use on how we want our plans to be constructed. So we always use OpenAI agents, SDK. We use light LLMs, open routers. So all our code is model agnostic, or at least the prototypes. The big downside with this, I'm not sure if there's many other Europeans here, is that it's more difficult to be GDPR compliant when you use light LLM and open routers. So in production, it's usually OpenAI agent, SDK, and then some European endpoint. But for prototyping, it doesn't matter as much. And this is really nice because this way you can just easily swap models in and out. And if this is already included in your planning stage, then it just makes life a lot easier. And then we usually go with hexagonal light structures, so hexagonal software architecture. We define a bunch of like variables that are important to us specifically, and like for these local prototypes, we usually use SQLite and Fast API. And then if we wanted to go really fast, we also have like Streamlit. There's some Streamlit prototypes, which don't even have like Fast API. We also have one where we use Streamlit as UI with a Fast API, and then 2 containers, which we can then deploy to Azure if we want to. So that's kind of the essence of it, right? And you'll see like there's nothing in here that really takes us to production. That's because you don't really architect software that often to take it to production, right? So that's usually like custom work that we only have to do when we like want to start a new flagship product or something. So that's not really part of this. But if it were, then it would be something like Fast API with Pydantic, and then like if there's a front end, it would be something TypeScript, React based, right? I think that's what most people are doing these days. So let's and then I also have this agent blueprint prompt, which will basically generate a plan of our agents that we want to create for a certain project. And we also have we also have the tester and development prompt. So to recap, how it usually works is we have some idea of some prototype or some application that we want to make. Then we'll pick, the stack that we want. So Fast API Jinja or Streamlit or something else. Then at the bottom of these prompts, you can always see like paste your idea below this line. And this is nice because that means that whatever provider, whatever model is best at architecting, for like a week, it was Gemini 2.5 Deep Think, and before that it was O3 Pro, and now it's GPT-5 Pro again. So you just swap between the models. And usually how I go about this, if I want to create some like internal tool, and just give you some context, our internal tools, like we build them once and then we actually keep building on them. So we want to make sure that the first time we make them, it's like already maintainable, scalable code. So no spaghetti code. And how it usually works is depending on what I want to do, I will pick a prompt, then I will just paste this prompt in, and then I will ideate with ChatGPT. So I will just use voice messages, transcribe, and basically spend like half an hour to an hour just going through the motions of what does this actually look like? What is the user journey that I want? So the user stories, what are the functional requirements? And then when I've gone through that, then I'll take the output of that, and I'll start a new session, and I basically paste it underneath here, and then you get a very nice verbose plan. Then when you have that plan, you can put that plan underneath this prompt, which will basically create a whole test set for your code case, and we'll get to that in a bit. So within Cloud Code, the only way you can really get it to work reliably, from my experience at least, it's obviously limited, is to really double down on test-driven development. But these models are quite prone to reward hacking. So you really want to make sure that the test-driven development, for that in itself, we also have like a standalone plan, right? So you'll see we kind of go through the motions of doing, you want to do unit tests, end-to-end tests, smoke tests with live API keys, and everything. Then when this is done, so you'll have two plans, right? You'll have your test-driven development plan. So you have your test plan MD, and then you have your plan B. And these two files, depending on the complexity of the application that you're making, either you can separate them and have like two markdown files you're working with, or you just append one after the other and they have your plan MD to get started. That's kind of the whole journey before you get to actually using Cloud Code. And then here, this is the fun part. So
Actually, a
I'm
real
actually
quick question
sure.
came into the chat before we move on from this section,
Mhm.
which is around for all of these sort of high level guidance prompts. Are these also generated by a model? Do you have like a base prompt that you use to generate them, or like how are you managing those kind of prompts over time?
Yeah, that's a good question. I mean, I've been working with these models for a very long time, so it's kind of intuitive to me. But we do have, so we have prompts for everything, right? And let's see. So depending on the subject matter, I will usually, if it's something I don't know anything about, like for example, we have this medtech project, like flagship product, and obviously I'm not a doctor, so I want to do a lot of deep research. So we have these prompts where you basically, same principle, you put your query underneath and it will generate a highly verbose, like super detailed deep research query for you, which you can then again put into ChatGPT or whatever model you want to use for deep research. Then we also have like user query to prompt, same principle. It's the prompt that helps you create prompts, right? So you put your thoughts underneath. And from my experience, I always just to speech to text, right? Because bandwidth that you have when you're typing, you're always going to take shortcuts. Whereas when you can just talk to these models, um, you will just use a lot more of your own tokens. Your bandwidth is much larger, and you'll, like from my experience, at least, obviously anecdotally, a lot of the times when you're like talking to these models or like recording this first message, halfway through, you're going to realize that something you said actually doesn't make sense. And then you just cancel and you go again. So you're kind of iterating with yourself. And then when you're
Totally.
happy,
Yeah, talking makes you
yeah,
think in a different way than writing does.
yeah, exactly. And then you put your ID models. So really what I do is I just find like all the papers and like best practices that the labs release. So OpenAI, Anthropic, always have this, they're like best practices for prompting their models. So I will scrape that. And then based on the documents that I've scraped, I will basically improve my prompt improver, right? And then you use that scrape documentation, you use the most intelligent model that's available to you, and you just like iterate on the prompt improver. So it's kind of funny because it scales pretty well with model intelligence. And we also have these like best practices, right? So we have like this best practices prompting playbook. You see you have some XML stuff here that's, specifically for the Claude model series. And then we have some best practices for the GPT-5 models. But yeah, that's long story short, that's like kind of how we go about it. So you just scrape what's out there, and then you take that context, and you ask the smartest model that's available to you to make it make sense and help you with prompt engineering. But it's very important that you, like, this whole phase of planning and prompt engineering, it is not a hands-off thing. You actually have to monitor it. It's and put in your own time, your own thought, else it's not gonna work. Okay, moving on. Right now, the flow that we have in Cloud Code, It's basically you start with your plan, right? So you use your architect prompts, and the moment you actually start in Claude Code, and maybe I can show you an example. Let me see if I have one here. It is okay. This is maybe a bit too proprietary. Wait, let me we grab something from another repository. Okay, so this is an example of a plan. This is for a nonprofit that I'm in, where we want to do some AI. We want to use AI basically for managing our social media advertising. So we wanted to create a Ninja front end, Fast API, Pedantic. We use OpenAI agent SDK, and this is the plan, right? So you can see it's over 1,000 lines. It's like 1 hour of iterating with GPT-5 Pro using our planning prompts. We have our test plan. As you can see, we have the test plan appended underneath our plan, the plan MD, so to speak. So the first part is focused more on like software architecture, data models, user stories, etc. And the second part is focused on purely on the test-driven development of it all. Then we have our Claude MD file, very heavily focused on orchestration. So in this setup, your Claude MD, maybe I can just start one here. So in this setup, your root agent, so to speak, is never actually going to write any code, right? All it does is orchestration. And how it will always start is, let's say you have a clean repository and you want to start with the implementation of your plan. You open it up, you tell it read Claude MD, and then this isn't actually the root repository, right? Which is why it's not looking for the plan. It's a sub repository. It's like just a prompt stash, so to speak. But what they would do is if you tell it, okay, read this plan, it will read the plan, and then that's when kind of the automation or the autonomous engineering comes into play. So the first thing it will do is it will summon or it will execute the architect agent. And what this will do is it will basically turn our plan, our markdown file, into a task list. And for this task list, we have an MCP server. So I wrote my own MCP server for this, and this one is empty. Let me grab one from a different repository real quick. Delete this one. So it's very simple. It's a SQLite database. And so the architect, what it does is it will go through the plan and it will basically create vertically sliced task lists for maximum parallelization. And then you can see it's a little bit bigger. Okay, so it will basically create tasks and then assign them to agents and execute them in parallel, right? So what's very important is that every agent, so we have one main agent to write code in this one. So it's the executor, who's a Sonnet, has access to Bash. That basically has access to all the tools. And it also has access to all our MCP servers that we use for this. So we use Playwright for like runtime testing. And then we have this Cord Hub Lite, that's the MCP server. Right. And what it'll do is it gets a task. The orchestrator agent is going to give it a contextual identity. So when the orchestrator summons or invokes the executor, it will give it a contextual identity. And within that identity, it will basically tell it, this is your task. These are the files that you can edit. These are the tests that you have to run. And this is the output that you have to generate. And the output that it generates is a task artifact. Let me see if I can find one. So it's always red to green, test-driven development. This is very small. Let me see if there's a better way to display this. So we use URI, we run tests, and it will generate an artifact. And after every time a executor agent runs, the orchestrator will always invoke a reviewer agent, because you can only go, so in our system, in this MCP server, which is being used by the orchestrator to do the task management, you can only go from, so a completed task, so the first iteration of writing code will always go to the status needs review, and that's the machine state. So even the orchestrator cannot simply move a task from like in progress to approved or completed. It always has to go through in review. And that means the orchestrator will trigger this reviewer agent. And the reviewer agent basically checks two things. It checks the output of the executor agent. So it will it will read the artifact. The artifact is basically a highly verbose summary of what the executor agent has done. Let me see, I think the template should be in here somewhere. Right. So this is the completion report. The task ID that I got from the orchestrator. Right. So the orchestrator will give the executor agent the task ID. That's the contextual, what do we call it? Contextual identity. Right. And then, when the agent is done, it will create this artifact. So the implementation context, the stack, the architecture, adherence to the plan. So every agent, so every instance of this executor agent. And remember, we can run 4 in parallel. We'll first read plan. It will read the framework guidelines. It gets from the orchestrator, it gets a concrete list of all the files that it is able to edit. So it will output in this summary, so this artifact that we write to our SQLite database, which is our MCP server, all the files that it touched, what it did, what it built, and the key decisions it made, the test results, passing tests, coverage, all tests passing, validation handoff, so ready for validation. When it has this status, that means it will be handed over to the reviewer. And then we have the actual outputs of the test, right? So what we mandate from these executor agents is that they have to basically deliver let me see, search it real quick. Right. So this is kind of an important one. Business value truth case. Why? Because these models are very prone to reward hacking, and you have to force them to show proof that the tests that they created, so red to green, test-driven development, so tests that they created, the green tests, especially in the phase where they're testing stuff at runtime, so like live API key, smoke tests, etc. They have to deliver proof that what they did is actually real. Because if we don't do that, then they will simply use mock data and they'll be like, yeah, sure, passed. And not really, like it didn't. And then after 3 hours of these agents running autonomously, you boot up your application and it won't even start because they just reward tagged the whole fucking thing. And this kind of fixes that, because the reviewer agent that comes after the executor agent is going to actually check the proof, and it's going to review the code, and it's going to run the tests. And if it sees, the reviewer agent establishes that the tests are faulty, then let's see, quick. Then it will basically hand the task back over. Oh, sorry for all the scrolling. So it will basically hand the task back over to the executor agent, and it will tell it what to fix, right? And it just goes back and forth until it is actually correct. And then the reviewer agent can say, okay, fine, this is approved. And then when it's approved, the executor agent, the orchestrator can then move on to the next task in the task list, right? From my experience so far, this is kind of arbitrary because, subagents are quite new. We're just on holiday for a while. I capped it at 4 agents running in parallel. Let's see. Let me share other screen real quick. Is my whole screen visible?
Yeah, we've got tabs and stuff.
Yeah. Okay. So this is just some stuff I was running earlier. So this is actually the nonprofit thing I showed you earlier, the plan. And this isn't running now, just to be clear. I got that bit limited. Unlucky. So as you can see, what it'll do is it'll basically hand over tasks to these reviewer agents after the executor agents run. We also have a release gate auditor. So every plan that we turn into tasks is in phases, right? So we have phase 1, 2, 3, 4, 5, 6, 7, whatever. And then after every phase, it goes through a release gate auditor. And that's, you can think of it as like a final boss kind of review agent, which will again go through all the artifacts that were created and test everything. So you can see well, this one actually didn't run too long. But most of the time, these will take quite a while. And when you do it this way, so you see like all these agents were running in parallel for quite some time. And the way that we keep it going is also quite important, is as through hooks. So we have a few hooks, right? So we have one hook that's when your root agent, so when you, root agent being like when you boot up Claude Code, like the agent you're talking to then stops, it will basically tell it you cannot stop, you have to resume. And what it'll do is it forces the root agent to do exactly this, right? So it has to run this command, get task tree tool, and it'll basically query the database, and it will figure out, okay, which tasks are approved, completed, merged, pending, or signed. Then if any tasks are approved, then it'll hand them over to the integration manager. The integration manager, you can kind of consider that to be like the agent that handles your repository, your commits and whatnot. And then after that, it goes to the release gate auditor. If there are any pending or assigned tasks that are ready to go, it'll run the ownership pre-flight, which basically checks, okay, let's say we have 4 executor agents who are assigned to their own tasks. Is there overlap between these 4 agents, the files that they use? Because obviously in this setup, we're not using separate Git work streams, right? So we have to make sure that all the agents you use are working independently on their own files. And then, okay, so it runs this tool. It sees, okay, all these files that we're giving, assigning to these executor agents in parallel, they're fine, like there's no conflict. Then it will batch assign a task, maximum 4. And then once it does that, then it will simply start these 4 agents in parallel. And that's quite important. So what you to do, and for some reason, it takes quite a lot of repetition to actually get us to do this, is you have to really force it to spawn these sub agents in one message. Because from my experience, what it will usually do is it'll say, yes, I'll spawn these in parallel. And then it'll spawn one sub agent, and then it's blocked. And then only when that one sub agent finishes, it can spawn the next one. So if it has to spawn all the sub agents, all 4 parallel in one tool call, basically, and actually run parallelized. So that's that. And then the Claude Code file, a lot of iteration went through this. It's like, this is basically just the whole workflow, all the agents, artifact-based completion, what agents are available to you, like how do you initialize when you start your session, the boot artifact. So to make sure that when you're running an app or when you're coding an application, that it actually works, right? You have to force these sub agents to actually run it, try it, and then debug it. Else like it'll go for 2 hours and won't work. And then there's a lot of just rules as to how the coordination has to take place. And this is very important. So it always goes from lead review, auto science reviewer, through, goes to validation, completed, goes to integration coordinator. These are all the sub agents just to be clear, as you can see on the left hand. And then no-go, basically it resets it, and it can either, depending on the severity of the issue, it will send it to the architect if it's like a fundamental issue with architecture of the code, like a structural problem. And the architect will basically alter the plan, and then the cycle starts. And then we also have these dedicated testing agents and a data review agent. So a data review agent, you can think of that. For example, we have one project where we're making synthetic data. So the data review agent will basically sanity check that the data that's coming out of your API calls to LLMs when you want to create synthetic data, excuse me, that it actually checks out with what you're trying to do. So this is basically just LLM as a judge in the form of Cloud Code Subagent. So yeah, that's about it. From my experience so far, this can run for, I would say, maybe 3 to 5 hours fully autonomously. The outputs, I would say, get to about 80% there. To be super honest, like I don't think we've had a single project where it just came out and like everything worked. There's always like some buttons that don't work or some tests that were reward hacked. We only implemented this business this business value truth gate. That's something we implemented today. So I haven't had the chance to really try yet. I'm going through those motions now. And so far, it's actually been really good. This whole value proof, right? So it has to actually show proof the test they executed, especially with API keys, or when they use this player to run tests, development server, or whatever. It was actually produced real output. Seems to have solved a lot of reward hacking, so I'm quite optimistic about that. And then we also added this validator agent, which basically is just a second. It's basically a final boss for the reviewer agent. So it will just try to build your Docker image. It will do smoke tests. It will basically just do all the and everything to make sure that there is no reward hacking whatsoever when it comes to the test-driven development. That's honestly the main challenge. The code itself, like from syntax perspective and architecture perspective, is okay. There's just they're quite prone to reward hacking. And then this one, so in your Claude code, in your settings, Claude bash maintain project working directory, very important. Else it's going to get lost in the sauce halfway through, and it'll forget where it actually works from. Then after, I think every 3 sub-agent stops, we re-inject the Claude MD file in the context window. Yeah, so then, okay, maybe just the last thing, like the framework guide, it's just like a project agnostic, like a playbook, like a cookbook of how do we want you to write your code? How do we want you to write your test? What is the target shape? What are some rules? Because we force every agent, every sub-agent to read the framework guidelines, the plan, and they get very concrete instructions from the orchestrator agent. This means that your code stays clean and maintainable, and you don't wind up with massive files and like stuff that's all over the place. Oh, and then maybe one last thing, and this is proven super handy, especially when you want to develop your own MCP servers or your own agents. Just take the time and scrape all the documentation. So I scraped all the documentation of Agents SDK, Open Router, MCP, Firecrawl, REST, MCP, and then also for Anthropic, Subagents, MCP, because our Claude code, so the agent, the orchestrator, when, let's say, for example, I'm developing an MCP server for Claude code, then it will also instruct the executor agents that this documentation is available because obviously it's not in training. So let's say they're working on some MCP server, and every executor will get in their prompt orchestrator uses to invoke them. It will get a path to this directory. We also have nice index file here. It basically tells the models what to grep. Like you see grep pattern, documentation, multi-agent, evaluations, MCP, fast MCP, and agents SDK. So it always tells it to read the index, and then it knows, okay, shit, I'm running into some issues getting this MCP server to work for Cloud Code. Then it knows it for Cloud Code with MCP servers. Exactly here, just saves a lot. So I would say anytime we're working on some project that has like some specific API, which the models aren't super familiar with, just scrape the documentation and make it available to your sub-agents, so and check before they write the code. Okay, I think that's
Awesome.
that's
We accumulated a set of questions. If you're game to go through some of the questions.
sure.
So I'm going to start actually back at some of the earlier ones. So actually, just tactically, Flo asked about: is there a VS Code extension that's letting you play with the .db inside of the IDE, or is that a part of Cursor?
Oh yeah, that is a VS Code. SQLite viewer.
Perfect. Next question from Kyle was: how are you framing the work when it gets handed to the reviewer agent?
So for that,
Yeah.
I meant like, how are you framing like who is producing the work and from what perspective they're reviewing it?
Okay, wait. Let me open.
Yeah. So personally with Cloud Code, whenever I ask it to review its own stuff, it finds it thinks it's great. If I ask it to review my stuff, it thinks it's great. If I ask it to review somebody else's stuff, even if it's the same stuff, it finds issues.
Yeah. So from my experience, that hasn't been a huge problem. I think that's probably because we set out like very strict compliance rules in there's the sub-agent markdown file. So you can see it reject. There's a whole bunch of rules, common violations, ACDD testing, and then there's like a protocol that has to follow for verification of the tests, right? And from my experience, if you're very deliberate in establishing for the agent what is good, what is bad, violation. So if any of these like protocols are violated, it must have the decision to these fixes, right? I think for me, that's kind of solved a lot of it. I think if you just ask, is it good or bad, and they most of the times say like, yeah, it's great, it's perfect, nothing wrong with this. If you tell it like very specifically, it has to adhere to these thresholds or these requirements, then it, from my experience, it does actually flag issues when they occur.
I got you. So you're saying just give it a rubric to work with.
Yes, exactly.
Thank you. Next question was Dirk. He says, I fail to see how handover from executor to reviewer is firmly defined. Couldn't that part fail easily, and then you only have part of the flow complete?
No. So the orchestrator, let's say the orchestrator invokes a bunch of executor agents, then it will set the task. So it will set the task to a certain status, right? So for example, I can set it to these fixes, but it can never move a task that's been executed and that's been completed by an executor to anything besides needs review. And then we also have a hook. We also have a hook that will automatically assign any task that was completed by an executor to a review agent. And there's a machine state in the SQLite database, so the MCP server, that doesn't allow the orchestrator to ever move a task, like change the status from a task that's been executed or completed rather by an executor, anything else that needs review. So only when this status of a task is approved, which can only be done by review agent through MCP tool use, then it can be to complete it. So there's a machine state guardrail that means that the model simply can't like reward tag themselves to skipping the review.
All right. Let's see. Next question is around the models that the subagents use. Do you dictate which models they're using? Are they just
Yeah.
default?
So depending on the complexity, for the executor, I use Sonnet since that makes up the bulk of the token usage. But then everything else is Opus. So just thing that writes the code is Sonnet, but the reviewer, the architect, the validator, etc., is all Opus.
All right. Let's see. Next question I saw was, have you considered breaking the validation into layers approached by different agents?
Yes, and we kind of do that. It depends a bit. So we also have like a playwright debugger. So for I'm sorry. So for some things, especially like runtime issues, the orchestrator can choose to hand off to a playwright debugger, and this agent is then specialized is a big word. Obviously, it's just a prompt, right? But focused on debugging issues using the playwright CP. And for our front end, so we also have a front end agent stack, kind of the same principle. They were like this. It's a bit different because it's like for front end, it's very hard. At least I'm not good at front ends, so maybe I should start with and definitely front end design. But it's been very hard to like just use like design tokens and stuff to keep everything like looking good. So we kind of went through this more esoteric approach. We have like this topologist, which will basically, so it takes screenshots and it ingests the screenshots of the front to make design decisions. So yes, sorry, that was a bit of a time. But yes, we do use specialized agents or sub-agents rather for review if it's necessary. And usually there will be the data reviewer if it's specifically for stuff that's like business logic related, like synthetic data that we generate. And we have front-end architect and we have a playwright debugger. And that's all we have. Maybe down the road it makes sense to have more.
Awesome. Getting through, I guess the last question I see is for the local documentation, which there's a lot of people chiming in and agreeing on that approach, and they love that. Do you do any sort of indexing of that, or how do you manage like which documentation is relevant when for what context?
Yeah, so we have the index file, right? So we have documentation, and we have the index directory. Sorry, the index file, and orchestrator, I believe, also has an overview, has a documentation guidance where we kind of tell the orchestrator which documentation is available to it, and then based on that, it'll read the index file, inform the subagents in the prompt and revoke what documentation they should use.
Have you considered an archivist role, or specifically like context and documentation management, who can like take that off of the orchestrator's context window?
Yeah, I mean that would make a lot of sense. I mean, I think what I have here is like version 0.01, which is probably going to get washed away by improvements in a few months. But I'm 100% sure there are 1,000 ways that you can do what I'm doing better by having more granular tasks and more granular agents and other system to handoffs. 100%.
Are you going to open source this?
Yeah, I think so.
Cool. Thanks. Anyway, I built my own version of this, but yours is much bigger. I think you've put more time into it than I did, and I like what you did.
Yeah, I hope it works. I hope it doesn't just work on my machine. It should be.
Awesome. This was super interesting. Lots of engagement in the comments. Appreciate you taking the time. I know it's late. I know you're sick. We've held you long, or even past when we thought we would. So thank you, Olivier. Really appreciate it, and hopefully we will hear from you again in the future.
Great. Thank you very much. Have a good day. See ya.
All right. Awesome. We have a few minutes left. If anybody wants to hop up and like discuss, debrief, insights, things you took away from. But we can also fairly whatever y'all prefer.
I think the local documentation thing and keeping that up to date was super cool. Like the discussion around that seemed interesting, and I want to make sure I post all the links that were in that conversation in the Discord. But that was kind of like a huge takeaway for me as someone who's trying to keep up with documentation. It was like just an interesting discussion. But I think the whole thing was actually pretty interesting. I think there is something to be said because like a huge part of that 400 messages that led to this call was that like there can be over orchestration, which I think there's probably some element of that going on. But I think overall, just to see somebody's workflow is always interesting every time, and I'll watch it every time. So yeah, those are my thoughts.
That you were touching on there, Olivier, where it's like this system that I'm building right now is probably not going to be relevant in, 1 or 2 model generations. So I think, to me, it seems like there's value in figuring out what's the minimum version of this system, because you're going to need to redo it from scratch 2 generations from now. So what you want to be able to do then is the minimum amount of work to get back to the kind of functionality that you're using here effectively. So I think
you'll probably but you just make it good enough so that it can make itself serving a generation.
Yeah, well, exactly. You could take it either approach where you could have a fairly sophisticated system that's built for a particular model that's spitting out littler systems, or you could have like these 6 or 7 fairly straightforward approaches will generally give me all the chassis I need to get this thing going, kind of thing.
Basically establish the primitives.
Another takeaway from
Watching him is like using
the
the
database for orchestration is really cool too. I think that's something yeah.
When you are using databases, I always have one test environment and one production environment, and name it like this, so the LLM doesn't delete your production database.
I'm a big fan of Neo4j myself. That's fun.
Yeah, thanks for pointing that out to me. Yeah, it's like a really good prompt is literally just like use SQLite or use DOL, and then put your task in it, and then it will create a schema and it will like use it, which is really nice.
I do have a question for everyone here, just because I don't have
a lot of experience with databases, and I'm checking out adult as we speak. But like, does anyone else, and Marcus, if you want to expand, does anyone else, while we have like I think like three minutes left, have any tips for like dealing with databases when it comes to agent orchestration, like in this sense? I would use MCP. I think it was Kyle and Marcus speaking, if I'm not mistaken. Kyle, if you want to go.
What I was going to say is just make sure you use something that's represented in the training data, because you can try to get like the latest and greatest of a certain X, Y, or Z thing, and it might make sense. But if it doesn't either operate on an existing schema that's in the data, that's in the training data, yeah, but if it doesn't do that, then you're going to have a hard time getting the LLM to recognize the commands it needs to use to interact with it effectively. But yeah, an MCP server obviates some of that. But even MCP server is like tools built to give the LLM handles, and it's like, I personally found that just making sure that the schema is indexed in the model training data makes a massive difference to the consistency of your LLM's ability to reliably interact with a database that's a full game.
Yeah, that's interesting. And it's Marcus. I don't know if that was you that was saying something about MCP or someone else.
Yeah, I would just page SQL, just page SQL, and within MCP.
Nice. Yeah, I looked into that. And then Dirk, it seems like Dirk in the comments is saying also he's a fan of Subabase, so you can like have your database in the cloud.
Yeah.
It often just makes things easier if you go from one machine to another or just collaborating.
Sorry, so someone who just spoke before you mentioned something about the MCP server and it not working. I was just curious, and what your point was again? If you talked about me and using the server and MCP servers wouldn't work, it's that regardless of how you're interacting with the database,
whether it's an MCP server or a custom tool call for the agent, then you'll want to make sure that you're using a database that operates on a schema that is like popular and like existing and been around for a while for best results. Because I was going between Falcor DB and Neo4j personally, and I really liked what Falcor DB had to offer in terms of features and functionality, but I personally found that Neo4j was just much better represented in the training, and it was just a much more accessible system to the LLM themselves.
and so
For that reason, I've just had a lot better luck since moving to Neo4j for that project, and my error rate has dropped substantially. And that errors compound over operations and over
a length of time you're using a system. So like even like a 1 or 2% difference is huge over like a mobile project, and I'm talking differences of like 20% more.
Question here on Falcor. Does that do you query both of those databases in the same way, but you have like different schema inside utilities? Is that kind of what you're getting at?
I forget exactly off the top of my head. It was the schema pattern of Falcor DB was I don't know exactly what it was, but they could not reliably query a Falcor DB database.
Interesting. Well, yeah, because my thought there is it needs to be represented in the training data, in that it needs to be able to it needs to have a lot of examples in the training data of ways to accurately query that database.
Yes. Yes.
And so as long as
query language.
Yeah. So as long as it's in Cypher or SQL, I think you're probably good.
Yes.
But if it has like a weird proprietary language, you're gonna be in trouble.
Yes. That's a very good point. If it was SQL or Cypher, then you're set.
We're at the top of the hours, gentlemen. If y'all want to.
Yep. All right. Yeah, I was just going to say thank you all. Great conversation. I appreciate everybody who participated. We do not have a speaker for next week yet. If you are inspired by this, if you want to go and tinker with something you learned today and come back and report whatever it might be, come speak with us, run the session next week. You can sign up by just mentioning the AI in Action bot in our channel. get it all autonomous. You don't have to talk to any of us human folks. Yeah, Kyle, Neo4j, if you want to bring a conversation about that. Doesn't have to be next week, but yeah, you all are what makes this continue to work. So bring the topics, bring the stuff. It doesn't have to be polished, just has to be interesting. And thank you all again. We'll see you next week.
Strong recommend for the Tool Use podcast. I'll post a link in the master thread.
Post it.